So good morning, everyone, and I would like to thank the conference organizers for inviting me to speak at this conference. Thank you, Edwina, for acknowledging and thanking the traditional owners of the land on which we speak. On a personal note, I would like to also acknowledge the traditional owners of the, please excuse my pronunciation, of the Whadjuk Noongar country of Western Australia, which is second home to a number of my loved ones. So I really want to acknowledge the traditional owners. And on a lighter note, the other day I was speaking with these youngsters in Western Australia, and they were busy vouching for the Matildas. I said, okay, you guys, you are now Australian, are you? They said, yes, Mom, we love Australia, but we are praying that the Matildas will win so that we are given a day off work. So, so I'm also rooting for the Matildas there. I have no conflict of interest to declare. So while antiretroviral therapy and pre-exposure prophylaxis have revolutionized HIV treatment and prevention, HIV remains a global threat. We know that to date, approximately 39 million people are currently living with HIV. In 2022 alone, there were 630,000 people who died from AIDS-related illnesses, and there were 1.3 million new HIV infections. Though these indicators show a slight improvement from 2021, the HIV burden remains unacceptably high. We know that pre-exposure prophylaxis works. We know that when used, Truvada and TAF and all oral pre-exposure prophylaxis, they work. But looking at 10 years after the approval of Truvada for use in high-risk people, in people at high risk for HIV, we see that the uptake of oral PrEP is not commensurate with the regions which are at highest risk for HIV. So there are still some disparities, some inequalities in terms of PrEP access, and there's a large unmet need for PrEP. And some colleagues here and myself, we worked on the dapivirine ring, and we showed that it has got modest protective effect in clinical trials. And also in the HPTN-083 and HPTN-084, we showed that cabotegravir has got remarkable protection against HIV in clinical trials. However, to date, dapivirine ring and long-acting cabotegravir are not yet available for HIV prevention. So we need a wide range of prevention options and programs to address the diverse needs of individuals at risk for HIV. We need people to have choices. They need to make choices in terms of what are the product formulations that they want. Yesterday, we heard from Natella as she discussed what adolescents like in HIV treatment. We worked on the VOICE-D study, which showed that women preferred various formulations for HIV prevention. So people need to have many options so that they can make a choice. They need to make a choice whether they want to use a long-acting, depending on the dosing interval. Do they want a long-acting product or a short-acting product? Do they want a systemic product, non-systemic product, a topical microbicide? Do they want a multi-prevention, a multi-purpose prevention technology like condoms? So there's need for choice. We also need our clients to have many choices, including passive and active immunization. But before I go to that, I would like to talk about the long history of use of antibodies to prevent viral infections. Since 1901, several Nobel prizes have been awarded for excellence in discoveries related to antibodies in infectious diseases, as you can see to the right of my slide. To the left of my slide, you can see a table showing various various viruses which can be prevented or treated with antibodies, for example, measles, CMV, RSV, and SARS-CoV-2. The takeaway message from this is that we know that in most effective vaccines in these viruses, the vaccines, they induce antibodies that neutralize pathogens. So what is neutralization? Neutralization is when the antibody binds to the virus and blocks attachment to host cells. So this is neutralization. But also antibodies work in other ways, for example, opsonization and sensitization. When we're talking about HIV prevention, neutralization, which is mainly a function of the antigen binding site, the top part of the antibody. So neutralization, a function of the antigen binding site, is the holy grail of HIV prevention. Opsonization and sensitization are mainly functions of the FC portion, the stalk of the Y, and they are also important. So what happens when one acquires HIV, or if one acquires HIV? I'll not dwell much on this slide. Thank you to Dr. Catherine, I think it was Catherine Barr, who talked about this yesterday morning. So we know that HIV transmission, initially within a few days, there's formation of binding antibodies. These start off with anti-GP 41 within days, and within weeks there's anti-GP 120 circulating antibodies. We know that these circulating antibodies have no effect whatsoever on viremia, but they're important in the diagnosis of HIV. A few weeks later, there's 50% of people who are infected, they develop neutralizing antibodies, just neutralizing antibodies. And strain-specific neutralizing antibodies, they arise within 2 to 6 months. So these are the strain-specific neutralizing antibodies. These are autologous antibodies. And these antibodies, they are responsible for virus escape because they neutralize the founding, the transmitter virus. So in a nutshell, we know that these neutralizing antibodies, today's neutralizing antibodies, they neutralize yesterday's HIV infection. And then broad neutralization arises after 2 to 3 years in about 5 to 30% of patients infected with HIV. And we know that BNAbs, they develop faster and differently in infants. So BNAbs have several advantages over other PrEP products. They are long-acting, they don't have a long pharmacokinetic tail, they are safe, they've got reliable PK across populations, and they are potentially immunomodulatory. They they provide us with another choice, and they inform vaccine development. So this brings me to a study that we conducted. We asked ourselves, can passively infused monoclonal antibodies prevent HIV infection in adults? This is the antibody-mediated prevention, AMP, trials, which were placebo-controlled, blinded trials of VRC01 monoclonal antibody, which was given high dose, low dose, compared to a placebo given on an 8-weekly schedule. We enrolled 2 cohorts at risk for HIV acquisition via vaginal intercourse and rectal intercourse, and both trials started in May of 2016. The study showed AMP was a proof of concept study. The results demonstrated that VRC01 could prevent HIV infection, but that prevention efficacy was dependent on the sensitivity of the circulating viruses to VRC01. Thus, prevention efficacy was high against viruses, it was as high as 88% against viruses that were sensitive to VRCO1. And this was the majority of the circulating strains, but there was no protection overall. The viruses isolated early in infection during the AMP trials, they provide a valuable tool going forward. There is evidence that over time, circulating viruses have diversified significantly and become more resistant to certain previously isolated BNAbs. So what this means is that in AMP, the viruses that were sensitive in 2020, in 2019, 2020, the viruses that were sensitive to VRCO1 were the viruses that had been there since 1998 to 2010. So there was like 13 years time difference between the viruses and the use of VRCO1. Antibodies were found to be generally safe and well tolerated. There were very low rates of infusion-related reactions that were medically managed. Compared to the placebo, both the high dose and low dose of VRCO1 were safe. The rates of adverse events were similar. AMP also came up with a putative surrogate marker for protection, the PT80. Just as a reminder, the inhibitory concentration, or IC80, is the antibody concentration at which the viral replication has been reduced by 80%. But this is not a sufficient correlate. It has nothing to do with the BNAb concentration in a recipient serum. This is where the PT80 comes in. So using AMP trial data, Gilbert et al., they showed that the predicted serum neutralization, 80% inhibitory dilution titer, which is PT80, the biomarker, it quantifies the neutralization potency of antibodies in an individual serum against an HIV-1 isolate. So this is in vivo neutralization, and they showed that this can be used to predict HIV prevention efficacy. So these are some of the successes of the AMP study, that it came up with a surrogate marker for effectiveness. And we know that the prevention efficacy, the PT80, it smoothly increases, as you can see here, the sigmoid dose response, the PT80 smoothly increases with PT80, both in AMP, as you can see in black here, in AMP, and in non-human primate studies. So these are the colored ones are the non-human primate studies, and we saw that the prevention efficacy, this is the prevention efficacy, it increases with increase in PT. And we see that a PT of about 200 is required to give a 90% prevention efficacy. So this is the biomarker that came out of AMP. So in summary, AMP trials showed that BNAbs are safe, VRCO1 protects against HIV in viruses that are highly sensitive. There was establishment of a putative marker of protection, and that future BNAbs require more optimization so that they are more effective. So what is the future post-AMP? Just as a reminder that VRCO1 was never intended as a product, and that AMP was just a proof of concept study. So the pessimists in here, they'll think the glass is half empty post-AMP, but the optimists, we can see that it is half full. As visionaries, we need to harness the full potential of these results. So yesterday, Dr. I think it was Dr. Cortez, she talked about the growth of BNABs, she talked about a rainforest, the clouds. A beautiful image from Spencer et al. Is what is summarized in my slide here. Starting in the 1980s, there were first generation BNABs with really modest breadth and potency. By 2009, there were enabling technologies, more broad, more potent BNABs, and in 2021, proof of concept from the AMP studies, and post-AMP, we have now more than 7 classes of BNABs which are targeting various conserved epitopes, and several are in advanced clinical development for both prevention and treatment. So there's the next generation broadly neutralizing antibodies. So we know that HIV exhibits genetic diversity and that viral escape is rampant in terms of HIV. We know that resistance to neutralization has been attributed to amino acid changes, the V1, V2 loop length, and additions of glycans. These observations suggest that viral panels, they need to be updated periodically to obtain the viral, the accurate sensitivity data for new BNABs. Remember I said that in AMP, VRC01 was neutralizing viruses which had been circulating about 13 years before we started AMP. So we need to periodically review the virus panels. So these results in AMP, they emphasize the fact that future BNAB trials, they require combinations of more potent antibodies with better coverage to improve overall prevention efficacy. Many phase 1 trials using more potent or broadly neutralizing antibodies are underway, including assessments of combinations or tri-specific antibodies. And we also remember that the predictive statistical modeling has suggested that second generation broadly neutralizing antibodies, particularly when used in combination, they can neutralize up to 100% of global HIV-1 strains. So from AMP to combo AMP, there are multiple BNABs which are targeting different sites on the HIV-1 trimer, and this was shown by Dr. Williams in the first plenary session yesterday. Here we see that there are many antibodies which are targeting various epitopes, starting with the CD4 supersite. There are many antibodies, the V1, V2 glycan, some other glycans, V3 supersite, CD4 supersite as well. And then we've got the EMPEROR, we've got 10E8V and 4E10, a number of antibodies here. And we've got the GP120, GP41 interface. So we see that there are many antibodies which are targeting different epitopes. And we see that the efficacy increases with combinations, theoretical combinations of these antibodies. So this is the way to go post-AMP. There is need to combine antibodies or to use antibodies which are multi-specific. So we also look at LS mutations. So knowledge of the structure of VRC01. It was used to engineer next generation antibodies with increased potency and wider breadth. So these antibodies, VRC07 is a clonal relative of VRC01, and there is VRC07 523 LS. So these were made from LS mutations. LS mutations just means there is amino acid mutation in the FC region of antibodies. And this mutation here improves affinity of the neonatal FC receptor. It increases concentration of the antibody in the mucosa, and it extends the half-life from about 20 days to 60 days, allowing dosing every 6 months, and it minimizes autoreactivity. Also, there is tri-specific monoclonal antibodies. Here, engineered tri-specific antibodies allow a single molecule to interact with 3 independent epitopes. So there are multiple epitopes which are targeted by the monoclonal antibody. So tri-specific antibodies, they thus constitute a platform to engage multiple therapeutic targets through a single protein and could be applicable for diverse diseases, including infections, even cancer, and autoimmunity. So we are looking at multi-specific monoclonal antibodies. Coming to antibody combinations, here I've given an example from Kong et al., where they are looking at 2 antibodies, 3BNC117 and 10-1074, which target 2 non-overlapping. So they target 2 non-overlapping epitopes as they bind to the antibody. In combination, these 2 antibodies, they provide better antiviral coverage as well as improved potency. So this is the combination. We see that it has got better coverage compared to the individual antibodies. We also look at theoretical antibody combinations of other monoclonal antibodies. The top panel here shows just an easy way to interpret this heat map is when you see blue, it means there's no neutralization. So the more blue there is, the less neutralization there is. We see here that PGT121 on its own, it only neutralizes about 40% of a panel of 208 HIV-1 strains. But we see that when PGT121 and VRC07-52LS and PGDM 1400, when they are combined, we see that there is significant and remarkable neutralization. So this is a graphic from AVAC, which shows the broadly neutralizing antibody combinations in the studies which are being conducted. This is a slide which just shows some of the engineered broadly neutralizing antibodies that are currently in clinical trials and the epitopes at which they work. So this animation, and Dr. Williams yesterday, he showed a different version of neutralization. So here we see the first part of this animation shows what we did in AMP, the neutralizing antibodies bound to HIV and prevented HIV from infecting the host cell at the bottom of the slide. And when we look at optimized antibodies like PGD 1400, PGT121, they act on different epitopes, acting on CD4, the CD4 supersite, V1, V2 glycan. And when we look at combinations of these broadly neutralizing antibodies, we see that they provide a stronger, more robust protection. So you'll see just now, compared to AMP, here the binding, the neutralization is more robust. So this is what happens with combination antibodies. So the summary, the question is, can antibodies prevent HIV infections in humans? We know that yes, antibodies are safe, they prevent HIV, but not always. Why is this important? The results help us to understand what a successful anti-HIV body response might look like in an HIV-vaccinated person, and the results help us to develop future HIV prevention methods, and they also help us to develop prevention and treatment interventions for other infectious diseases. I believe we were successful in COVID because of the lessons learned in HIV. And may I refer you to an interesting commentary by Shelley and Linda and others in the Journal of International AIDS Society, where they talk about HIV, antibodies for HIV prevention, what is the path forward. So that commentary, together with the WHO preferred product characteristics for monoclonal antibodies for HIV prevention. They talk about the favorable attributes of an optimal BNAB for HIV pre-exposure prophylaxis. The optimal BNAB must be safe, highly efficacious. It must be simple for prevention and treatment. There must be streamlined regulatory pathways. It must be affordable and scalable, and it must not trigger the production of anti-drug antibodies. So in conclusion, the future of BNAB research must be a human rights-based approach. The BNAB HIV prevention is evolving faster than ever. Research must reflect diversity, equity, and inclusion, and research must uphold justice and beneficence. It must target the highest prevalence regions and the special populations, and it must begin with the end in mind. But most of all, it must be framed by a human rights-based approach. My colleagues and friends from the Rainbow Nation South Africa would say that research must reflect Ubuntuism. But what I learned in my time in Australia is that the First Nation tells us that respect is for all and harm to none as we conduct future BNAB research. Thank you very much.